Welcome everyone, and in this video I'm still discussing mixtures, and we're in the last stage whereby we are talking about liquid mixtures. And in liquid mixtures, in our last stage now, liquid mixtures, where we're supposed to handle types of liquid mixtures. There are two types. There are two types of liquid mixtures, where we have miscible and immiscible liquid mixtures. Now, in immiscible liquid mixtures, I'm just going to go give an overview of it. You don't really need to know much about it. In immiscible liquid mixtures, there are different techniques we can use, and I'm going to give you example. In immiscible, we have different techniques we can use in separating them. And the examples first, let me give you examples of them. Examples: we have water and paraffin. Paraffin. Even can even have water and petrol. Water, oil. It can be cooking oil. Yeah, those are types of immiscible liquid mixtures. And techniques we can use. Techniques we can use. We can use decantation. You can use separating funnel. Sorry, let me write it very well. You can also use a separating funnel, in which you can have a separating funnel as also a technique. Or I can even use a pipette. A pipette or dropper. Drop. Majorly, we always use separating funnel. And I'm going to sketch how a separating funnel looks like. But as far as decantation is concerned, imagine a situation where I want to use decantation. Most immiscible liquid mixtures looks like this in a beaker. I'll have a beaker in which I'm having a mixture, and the two mixtures are immiscible, meaning a layer is going to be formed. So at the bottom, I can have my denser part of the mixture. Then a layer is going to be created between them. I'm going to treat this as a layer. Then at the top, I'm going to have the lighter part of the mixture. Now, so I can go ahead and say this is denser liquid, this is less dense or lighter. It's lighter liquid. So the one that is denser will be at the bottom, and the one that is less dense will be at the top. Now, I can decide to subject these two to separation techniques, meaning I can use decantation. I can decide to use decantation, in which this is how it is going to appear. I'm going to have a clean beaker that looks like this, and I'm going to have my beaker containing the mixture. My sketch is poor. Yeah, I'm going to have the beaker containing the mixture. Yeah, I'm going to have the beaker containing the mixture tilted. So this is how it is going to appear. This is how it is going to appear. So I'm going to have this. Now I have to ensure that I draw it the way it was drawn initially. Yeah, that's where the layer will now. Sorry, I did not say this is a layer between the two solutions. It is just a layer between the two solutions because they don't mix. Don't forget that. Then I'm going to have my top solution, which is now this one, that is pouring out. So it is the one pouring out. So meaning in my next clean beaker, I'm going to have the top solution poured into into a clean, into a clean beaker now. So I have to write it somewhere so that we don't forget. So I'll have to say the top liquid is poured into a clean container. But there is a problem with this technique. That's the reason why mostly it is not used. The problem is anyone who is using this technique must be careful not to pour the layer out, the layer between the two solutions out into the other beaker. You have to be very careful while pouring this in such a way that this layer here shall not spill into your new container containing the top liquid, the mixture. You have to be very careful of the layer because the two solutions were not mixing. That's why there was a layer between them here, this region here. So you have to be very careful. That's why mostly decantation is not used, because some people tend to shake whenever they are doing the practical. So mostly you will find that traces of the layer might be found into your new top layer solution that you are trying to separate. That's how we can use decantation. The next technique that I want also to explain is a dropper. A dropper works this way. I can use a dropper. I can use a dropper. A dropper works like this. Now, into the beaker that was having the mixture, you know very well that the top layer was the lighter one. Now, what I'm going to do is a situation whereby I'm now going to have my layer. Yeah, the layer is there. Then I'm going to have my maybe the top one was the red one. Sorry. Let me just draw it the way it should be. Let me rub this and draw it the way it should be. Now I'm having this one here because I wanted to see whatever thing that is happening. The bottom one was the red one, so I'm going to use a red color to show that. Good. Now the next thing that I'm going to do, I'm going to have my bridge or the layer between them. Then the top one was black. Yes, let me use black. I wanted to see how we can use a dropper. So we said initially this was denser liquid which was forming in the bottom, then this is light liquid. So when I subject this to a dropper looks like this. Dropper is always a substance that looks like this. and it has a sharp tip. Sorry, it has a sharp tip. Yeah, which you can use to suck the solution. It's not really drawn well. Let me try drawing it well. I'm artistically challenged there. Yeah, I can have that. Then here I'm going to have that coming that way. Yes, at least that now can work. So in my new beaker, that is going to be this one. That's my new beaker. I'm going to be sucking the top layer. I'm going to be using it to suck the top layer. I suck the top layer. Then, as I'm sucking the top layer, I empty it into this new beaker. So a situation can come in which now I'm going to have a situation whereby if I suck, it's going to be less bit by bit. Sorry, it's going to be less bit by bit as more is deposited here. I can suck the top layer. So when that happens, you'll come to realize that this one will be getting removed until we reach the layer. Then at the end of the day, I'll be having the layer. Then I can pour off the layer now. This layer can be poured off because I'm using a dropper to suck off or out the top layer, the top solution, I mean. That's what is going to happen when we use a dropper. At the end of the day, I'll have the two solutions in different containers. But majorly, in chemistry, majorly, a separating funnel is used. A separating funnel is used. We use separating funnel. A separating funnel is used majorly in chemistry to separate immiscible liquid-liquid mixtures. And this is how a separating funnel looks like. It is always drawn in a funny way. I want to try. No, it's not like that. I want to give it a try. Yeah, I'm going to have this. Then I'm going to have that. And that. Then it is having a knob. So at this point, it is having a tap. It is having a tap. So it is in this that we pour our solution. So if you check, we had the red one and the black one at the top. So I'm going to have the black one at the top like that. Then my bridge or the layer between the two solutions. Then at the bottom I'm having a red one. So it is supposed to be filled. It will be filled until you reach the top. So this is a separating funnel. This is what a separating funnel looks like. Most of the time it is always found in the lab. Whenever you want to use it, you can always find it in the lab. Now, how does it work? It works on the principle of gravity. It uses the principle of gravity. So what happens is when the tap is opened, on the tap, is opened, the bottom layer stroke the denser liquid will pour out first. Will pour out first. Then, when you're about to reach the layer, you remove the layer is poured out. When you're about to reach the layer, then lastly, we say the top liquid part will remain in the separating funnel. It will remain in the separating funnel. So when that happens, we say we have separated the two solutions. So what we have to be careful about before when this is done, we must always have a beaker within which the top solution is going to pour itself out because it was the one forming the bottom layer of the mixture. So when the tap is opened, it will always pour out. And that's how we can separate immiscible liquid mixtures. Thank you very much. In our last video, I'm going to talk about how we can separate miscible liquid mixtures, and it will be the end of our mixture as a subtopic in principles of chemistry.